Hello, AP students. This is the review for the quiz 8. Sorry the video is being uploaded very late at this time. I'm going to go over these as swiftly as possible. And for most of you guys, I believe there might be only just a couple of questions on quiz 8. We did most of the questions in class together. So yeah, let's get right to it. So number one, it says that we have a least squares regression line calculated with the correlation of 0.74. Which of the following is proper and most informative conclusion for an observation with a negative residual, it says. So if we have 0.74 as a correlation, I believe that I've asked you guys to change this to a residual of negative 0.74. But quite honestly, if you still maintain this question and still try to answer it with understanding the last component of the question, you can still get it. So what this means is that you have a correlation of a 0.74. So you have some sort of a positive, let's say a least squares regression line. Then it says proper and most informative conclusion for an observation with a negative residual means that your predicted will be below the actual dot. I'm sorry, the actual. Sorry, let me just erase all this. The residual is always actual minus predicted. So if we are considering the fact that observation with a negative residual means that if residual is less than 0, it means that actual has to be less than the predicted. Because if I do actual minus predicted and it becomes a negative number, that means that the predicted is actually the one that's higher. So this point is on the line, which makes it predicted. Then the actual is actually less than the predicted. In other words, the residual is negative. It's below the line. So the predicted noise is 0.74 times. We don't want to say it's any multiples of anything like that. The measured noise is greater than the predicted noise level. The predicted noise level is greater than the measured noise level. It's actually D, so that the predicted is actually higher than the measured, or we call this in this case actual. The slope of the regression line at that point must also be negative. No, the slope is going to be positive because the correlation coefficient right here is positive. So none of the answer choices will make sense other than D. Number two, I just take a look at that and go, something's really off, because remember, the correlation coefficient always has to go from between -1 to +1. So this is just E. There's got to be some sort of a mistake made. There's no way that you're going to get a correlation coefficient that's beyond +1. The question number 3, we did this in class, but basically this one is going to be always your slope. This one is always going to be your y-intercept. This one is your explanatory variable. And so the other response variable would be the context in which it's going to be back. It says facing and back. Those two are the only variables that we're dealing with. So we're going to say hat back with a hat. That is the first thing I need to take a look at, because that's your response variable. In other words, that's your y hat. You're going to have to start off with that. And so plugging in the y-intercept, 0.05590 plus 0.92003 times x, because it's m, a plus bx, basically. So the only answer that makes sense with that should be B for this one. What is the correlation, it says? Well, the correlation comes from this least squares regression. The R squared, 98.6% is basically your R squared. So 0.986 is your R squared. So if I just pull up a calculator here real quick, so I'm going to do square root of 0.986, and it gives me 0.99. So that means that I'm going to have a correlation coefficient of 0.99, about that much here. So the only answer that actually makes sense with that should be E. Just double checking my answers. I don't think I have, 0.993 should be the correct one. Okay. All right. So number 5, for one player, winning the game proportions were this and this. So this means it was facing and this was back, respectively. So this was your X variable. This was your Y variable when you actually found out did actually the game winning proportions. This was the actual data. It's talking about finding the associated residual. Remember, to find the residual, we always want to do actual minus the predicted. The actual here is the actual back value that you got which is 0.59. How do I get the predicted? Well, all you got to do is just go back to this equation, right? So I'm going to bring this down here. 0.05590 plus 0.92003x. So if I plug in 0.55 into the x, because that's your explanatory variable, then you're going to get the actual predicted amount for that equation. So here, I'm just going to type in 0.0559 plus 0.92003 times 0.55. So that gives me 0.5619165. That will be my predicted value. Remember, our actual value was 0.59. So actual minus the predicted. This will be the shear residual right here that you see on the calculator, 0.02808. So I'm going to go through my answer choices and just simply pick that one. Since our actual is bigger, so it should be positive 0.028. So that should be the correct answer here. Okay. All right. Moving on to the next question, number 6. What percentage of the variation in the GPAs can be accounted for by looking at the linear relationship? Guys, this is just an exact context of what R squared is supposed to be. So you take this value and then you square it, and R squared actually gives you about 0.399 for this. So we say what percent? The R squared percent of the variation in the GPAs, which is your response variable. Look at that. That's your Y. Can be accounted for by the LSRL between the GPAs and the SAT scores. With the GPAs and the SAT scores, that's your explanatory variable. So it's just simply C for that one. You just have to square the R value and you're done. Suppose the correlation between the two variable R is 0.23. So you add, every value of Y variable is double. You multiply it by 2 and 2 variables are interchanged. No matter what you do to the data itself, I mean, you can try this with, creating your list 1 and list 2. You can see this for yourself. 1, 2, 3, 4, 5, and then try like 6, 7, 8, 9, 10. Apply these changes, like add all the 14s, double all the Y values here, and then even swap them so that your list 2 becomes list 1, list 1 becomes list 2. Your original R value of 0.23 will never change, or in this case, you'll get an R value of something. After all that change, your R will still be the exact same thing from your original. So your R value doesn't get impacted unless you multiply by like -1 or something, like all the values. So every values now becomes from positive to negative, then your correlation will actually change into a negative correlation. That's how you can actually physically change the correlation coefficient. Otherwise, it's like one of the strongest resistant thing that you will see in statistics. So it's just pretty much the same, 0.23. So that would be C. Number A, slope is 0.377 R squared and S is given. A lot of you guys asked me a question about this. So first of all, if I actually add a point from 35 to 14 like this, you can see that if I were to draw like an imaginary line, that was actually not a good one. So let me try my better one here. Okay, so my ultimate idea is that this is still bad. Okay, that's much better. The best line of fit for this has to go through this point, or it may seem like it goes through it or very close to being that point. In other words, the residual for that particular point is very small, almost close to being 0 for that one. So what that means is if that particular point was added on top of all of these dots right there, your correlation coefficient should increase because now your line is even a better fit because the point actually goes through the line. Your residual actually got decreased overall in total when we find out the average. So your slope can still stay the same because your line will not change by that much. So E is out. But your correlation coefficient has to increase from 95, which means it will overall increase the R squared coefficient of determination. So rather than saying 93%, it's not going to decrease it. Rather, it's going to increase that. Now, when you have your stronger point on the line, which decreases your residuals, First of all, this is correlation, not your residuals, by the way. Your residual is going down. So if your residual is going down, it's getting smaller, it's getting narrower of all the residuals. Like if you were to calculate all of these residuals, and then like if you try to find out the standard deviations of it, because one of the residuals that we point at it is 0, it actually makes the overall span of the residuals to be a lot smaller, because this actually gives me the smallest residual possible of 0. Therefore, the standard deviation of the residuals actually has to go down because the residuals are getting smaller, or better yet, this point has a very, very small residual of being close to 0. So if the original standard deviation of the residual has 0.64, which is right here, that means it has to have something smaller than that, so that it's gonna pick, it's gotta be B. It's not going to increase the standard deviation of the residuals. If this were to happen, you had to pick a point that actually gives you a bigger residual compared to all the rest of the data, so that your overall residuals increase up, like the average goes up. Okay. All right, next question. So here, what does this negative mean in this context? Quite honestly, the biggest obstacle when we're doing these AP stats is like reading over these answers and trying to pick out the best answers choices. Sometimes it works very well, sometimes it doesn't. For this, I don't think it's going to be a big problem. It is predicted that 11,100 highway deaths due to failure to wear seatbelts. Okay, so this is really focusing on this number. If no one wore seatbelts in a given region, it is predicted. So this is actually describing what this 11,000 number is about. The correlation R between the number of highway deaths due to failure to wear seatbelts and the percentage of seatbelt usage is negative. Okay, certainly because the slope is negative, we can actually expect this to happen. So I'm going to put a little check mark on that. If a given region has a lower percentage of seatbelt usage than the second region, then the given region will have a higher number of highway deaths due to failure to wear seatbelts than the second region. Okay, so we're talking about regions. Given region has a lower percentage of seatbelt. So I'm assuming that this is going to go down like this. This is belt usage, and this is deaths. So it has a lower percentage, which means we're talking about this one. Then the second region. So this is your first and this is your second. The given region will have a higher number of highway deaths due to failure to wear seatbelts. Okay, so if you think about it, you might assume that that might be the case. But remember, the dots could be like here, and then like it could be like here. There could be so much variations to this, as long as it has a negative correlation, right? So not only is it, sometimes there's going to be an outlier. So if I can just pick a region down here and then the compare region there, sometimes the deaths could be lower in the lower belt usage compared to higher belt usage, and you can have higher deaths. You never know about that. So this one's a little iffy. If I had to choose, I would definitely just like eliminate that for now, because B is certainly like a better choice of an answer if I ever saw one so far. D, region with a higher percentage of seatbelt usage tend to have lower number of highway deaths due to failure to wear seatbelts. Okay, so with a higher percentage of seatbelt usage means we're talking about going in this direction on the higher end, tend to have lower numbers of highway deaths due to failure to, so have lower numbers of highway deaths due to failure to wear seatbelts. Okay, I don't really like that word, but basically what this first sentence, like after this, is perfect in describing what we want to say in terms of statistics. Tends to have lower numbers. We want this soft cushioning words, as I like to say it, cushioning words, right? So higher percentage means that obviously, because based on the predicted line, higher percentage of the belt usage, we get lower deaths amount, or it tends to be in that behavior. So this one I do like. C is like, if a given region has a lower percentage of seatbelt usage, the given region will have this. We don't want to say will have, we want to say will most likely have a higher number of highway deaths. So if they had said like the word likely in this chances, then it will be a much stronger candidate for it to be an answer. But this is just straight up saying if cause and then effect. We really don't want to say that in statistics, especially describing two different types of associations here. E, if a region has a 1% gain in the seatbelt usage, then it will have reduction of 305 highway deaths due to failure to wear seatbelts on average. This is predicted amount. And this is talking about 305. we're talking about what does the negative mean in terms of context here. So we really want to focus on the fact that as one increases, the other decrease. That is the main idea we want to describe when they're actually talking about the negative portion. So what I'm going to do is I'm really just going to highlight this. The correlation R between the number of highway districts you fail to wear seatbelts and the percentage of seatbelt usage is negative. So yes, the correlation is definitely negative, but if we're just talking about straight up B here, B is talking about the correlation itself and not the fact that it's talking about the negative of this context. The negative in this context is talking about this. Regions with a higher percentage, so as one increases, the other one decreases. Remember, they want you to use the terms of the context. B is just straight up talking about the correlation. It's really not, I mean, it does give me context at the end, of course, but it's really high, it's focusing on the R value itself rather than the negative. What does the negative mean? That is what you want to say right there. Okay, so the correct answer here, I know I marked like crazy amount of stuff here, but then I'm just going to highlight this. The correct answer should be D for this one. Okay. All right, next. This one, you just simply have to do B equals R times SY over SX. So that should be 0.15 times 42K over 1.3. Okay, so I have to use my calculator one more time. So 42,000 divided by 1.3 times 0.15, and I get 4,846. That's the only slope that I get, so why bother? I'm just going to move on. All right, consider these following points. What should be the value of n, so the correlation between x and y is 1. Guys, if the correlation is 1, it means that it perfectly falls under one line at the same slope. So what that means is if I go 2, 3, 4, 5, and 10, it seems like there should be a pattern. So then the next one, so the y value gets increased by 2s each time, it seems like. But wait a minute, if I compare 9 and 12, it actually increased by 3. So no matter what I plug in for n, because there's an inconsistency in the pattern amongst the points, I can't make these set of points to have an r value of 1. It's not going to fall perfectly on the singular line. This one we did together. Remember, if that's your best line of fit, the leverage is always how far you're deviating away from the average in terms of x's. It seems like x is falling right on the money of where the average are for all those scatter plots. So the low leverage is the one you want to go for. And the residual is a measurement of the actual minus the predicted. So this actually does contain a high residual. Sorry, I should not use R because it might get confusing with the correlation coefficient. So the residual is very high. So I'm going to say C, and that's going to be the correct answer here. Okay, all right. So now we're moving on to the free response questions. So the scatter plot I have, and this is medication, and this is pulse rate. So let's take a look at the questions of what they say. So find the correlation coefficient. You just have to take that and you have to square root that, right? So go to your calculator, square root of 0.819, and then bam, I'm going to say correlation coefficient 0.904. And sometimes if it asks you to interpret what this means that it is a very strong positive association between the pulse rate drop and the medication and the grams of medication. So that's what you want to say possibly when you're asked to interpret what this correlation coefficient represents. What is the slope of the regression line and what does it signify? Okay, so that means we're going to say it's 8.5. But what does it signify is that for every 1 gram increase in medication, so remember, every 1 gram or every additional unit of the explanatory variable as it increases, then your pulse rate increase by 8.5 beats per minute. So that's what this number represents. For every 1 x variable, the y variable increases by that much. Predict the pulse rate drop for a patient of 2.25. Okay, so this just means I just need to plug it in right there. All right, so I'm going to bring my calculator one more time. So 2.25 times 8.5. And then you're going to add with the negative 1.68. So I get 17.445. So I'm just going to say that predict the value 17.445 beats per minute is the predicted amount at the 2.25 grams of medication. Patient given 5 grams of medication has his pulse rate drop to 0. Okay, so that means that if I were to go like this, 4, 5, I actually have a dot that looks like that. So you can see how odd this looks like. I mean, there could be patients like this in the real world data. You never know what's going to happen. So does this invalidate the regression equation? Well, first of all, it doesn't invalidate the regression equation. So no, it's not going to invalidate it because, you know, the 5 is something that is not part of this graph. So you're doing something called extrapolating. There's always something called less reliability when we're extrapolating something. So if you extrapolate this general trend of the data to predict what's going to happen at 5, you can probably see it at 5. You're going to have a lot of pulse rates if this continues to happen into the future. But let's say that this is the actual data that we got. Okay, so it happened, but this doesn't invalidate it because you have what you're doing is you're doing something called extrapolation, so that this line only goes so far as to predict the behavior in terms of going up to medications of 3. It can predict very well what's going to happen within the given boundaries. When we're entering the realm beyond the 3, because now we're trying to predict the future, it's always less reliable or even barely reliable using the prediction line because you never know what's going to happen. So I believe the answer key said that, you know, extrapolations and all that, and because you know, 5 is not part of the scatter plot, that's why, you know, there's something like that could possibly happen. If I were to just take a look at the answer key just one more time here, there's always a danger using, okay, overdose, the patient died, cannot be used for such lines. So if I'm ever asked this question, does this invalidate the regression equation? No, it does not, because it's extrapolation. So the best line of fit, actually, you can't really use that to predict something that's beyond the 3 as reliable as it once was when it was just the 3 grams of medication. Okay, so all of those things, I mean, obviously these are the words that I really want you guys to say it, because those are the main vocabularies. So basically say that, you know, it's beyond the given scatter plot range. So it's always less reliable to use the best line of fit. Therefore, it doesn't invalidate it though. This is the main idea. It doesn't invalidate the equation. How will the size of the correlation coefficient change if the 3 gram results is removed? So if this was to be removed, notice how what's going to happen is that, like, because this dot is here, it actually tilts the line more like in this fashion, where it goes a little bit towards that 3 gram dot. But now when I exclude this, I'm going to use a different color. Now, if you just straight up look at all of these dots, it's going to look more like that now. You guys have to draw you guys have to have a very good idea as to how the lines will move around if the point was removed or added. So if you compare these two, you can see how the correlation coefficient will obviously increase because a lot more data is now congested around those dots, you know, for the blue line. Whereas if I were to have that little line, like the dot at 3, it's actually further away from all, like, the red line. So the residuals is higher, therefore your, you know, correlation is actually lower than before. So if I'm going to talk about the correlation, it increases because the dot at the 3 gram data had large residual. So therefore it had a strong impact on the correlation coefficient, strong impact on also the slope, because, well, the slope actually doesn't get impacted a lot, but basically what you want to say is the 3 gram data had a large residual. So by removing it, it actually increases the correlation R overall. For part F, how will the size of the slope? The slope obviously increased because look how steeper it is. It's steeper. So if the slope of this was like, I don't know, you know, like it's about the incline, right? So this is at 0. This is like, you know, half, like, let's say call this one, you know, 2 is like even higher incline than that. So if it's a higher incline of the line, higher incline slash steeper slope, steeper, then it's the higher slope. So the slope will increase for part F. That's generally what you want to say. Guys, this is a very abbreviated answer. Obviously, you want to elaborate on that by, writing down a couple of sentences, but that's generally the idea of what you want to say. And I think, yeah, that's what the answer key says as well. Number 2, Facebook and MAU. So describe the relationship between MAU and the year. So that's DOFs, by the way. Okay, so this is not describing the distribution. This is describing the association, how good of a line best fit of line is. Obviously, this is not a line. This is non-linear format. That's for the form. Outlier, I do not know, and I don't quite honestly have ever seen an example which it gives you have to write an outlier. D is the direction, so that's definitely positive. And the strength is that's very strong. I mean, this is a perfectly calling for like a very nonlinear format. So there's a strong, positive, nonlinear relationship between MAUs versus year. Or year versus MAU, because usually you want to swap up the X's and Y's, like X versus Y. And that should be the answer, I think. Yeah, there should be it. The regression analysis, log MAUs versus log. So this, obviously, please note that that's the power model that they're talking about. And this is the residual that you get as a result of that. So that should tell you something, first of all. Interpret the value of R squared. R squared is right here. So 97.9% of the variations or variability in the response variable, which is, I think, is MAUs. Oops, sorry. In MAUs, that is can be accounted for, can be accounted by the least squares regression line with the explanatory variable. This is just a very abbreviated one. Just go back to the template and you will see how similar this is. I mean, there's the word variability, the response variable, you plug it in, accounted by the least squares regression line with the year or number of years or something like that. And so that, I think, for the answer key, it said can be explained by the linear relationship between log MAUs and log year. Yeah, so for this one, the only thing I just kind of missed out was the MAUs has to be logarithm, because we took the log of MAUs, which is here or here and here. So you want to use the context of the X's and Y's, and then but then the template pretty much stays the same. So it can be accounted for by the LSRL with the log of the year, like that. Is it appropriate to use a linear regression model? No, because there's definitive pattern. And so there's straight up no pattern in the residual. So therefore, whenever we ever see the residual like plot has a pattern, we don't want to use a linear plot. So we just say, okay, no, there's a pattern in the residual. So the least squares regression line is appropriate. The linear regression model to transform, it's still not good enough because there's a pattern. Okay. All right, I'm going to go through these swiftly as well. Number 3, how do the outliers 2 and 3 affect the correlation? So obviously this one, the correlation is definitely negative. This makes it positive, and this makes it sort of flat, makes it almost equivalent to 0. Insert a fourth point in 1 so that the correlation doesn't change. Just follow that line and you can add a point like that. So it just still follows that negative correlation. That was easy. Number 4, continuing graph 1 scatter plot showing the amount. Okay, so we have to really account for the X here. So I'm assuming that's super important. All right, so describe the association between the stress level and the depth of these 25 sample college graduates. All right, so there is some sort of I mean, you can draw a line. And I mean, for this one, if you take a look at, they don't even give you the R value in this case, which is kind of unfortunate. But you just really have to make a judgment call on this. You look at all these dots and go, okay, are they really clustered around that line? Or are they somewhat like clustered around that line? Seems to me, I would use the word somewhat. They're not really, perfectly around the line, but they're kind of show a positive trend. I can see that. And this is somewhere I'm going to just say there's going to be a moderate, positive, linear relationship. between the stress level and the depth. And I believe for part A, yeah, the linear, moderate, and positive, that's what they said. This is your DOFs right there. And in this case, we usually eliminate the O's because outliers are never really mentioned. So moderate, positive, linear relationship between these two statistics. The point labeled X represents a student with 60,000 debt and stress level 25. Calculate and interpret the residual. Okay, so here we have the equation 0.42640x plus 19.376. All I'm going to do is I am going to plug in our debt, which is 60,000, but it's in thousands of dollars. So I'm going to plug in 60 for X here. So I'm going to go to my calculator. So let me zoom into this. So 0.42640 times 60 plus 19.376. So that's 44.96. 60 minus that actual minus predicted. So it gives me a residual of 15. Oh, I'm sorry. Wait a minute. That's not 60. I should say 15. Oh, stress level is actually 25 minus the answer that we got from the original. All right. So that residual here should be negative 19.96. So your actual stress level was 25, but your predicted stress level actually came out to be about 44.96. So you do 25 minus 44.96. So you actually get a residual of negative 19.96 here. Does it say to interpret this? Yeah. So calculate and interpret the residual of that point. So the way that you interpret what a residual point is, it would be like basically at for the student who had 60,000 K in debt, the difference of the actual and the predicted and the predicted will be around negative 19.96 of stress level. Just giving some sort of a description of the sentences. This is something that I would say on the spot. So the residual value means that the stress level is 19.96 points less than what will be the predicted. So actual minus the predicted is about 19.96. That's what the answer key said. Something along those lines is basically how you would describe it in your own words. Okay. This is the last question for quiz 8. And quite honestly, a lot of you guys might be really confused about this, because they involve some other, like the second explanatory variable. They just call this out of nowhere and then just ask you to quite like somehow explain which of these two better explains the like the relationship between the residual from regression of the stress on depth versus the other explanatory variable here. Now, the problem is we haven't actually done a question like this before, where they actually call us straight up another explanatory variable and ask you to compare. Remember, yes, I always told you guys for the residual plot, we are always talking about the randomness in things. So the more randomness we have, the better the linear fit will be. But if we're trying to involve a secondary explanatory variable and comparing that with a like usually you know how it says a residual on the y-axis, this one says residual from regression of stress on depth. So what that means is that this is the actual, like these are all like the residuals, but in terms of health-wise, like you move all those things around, all those residual plot that was originally like this. So residual, and your X should have been this, depth. Okay, and so you should have had something where obviously because we have some sort of a linear model, so you should see us scattered all over the place for the depth versus residual. But now what's happening is you take these residuals that you have and you sort of organize them in such a way that this is no longer called depth, this is now called health, for example, this one. And then the residuals are all kind of the same, like from the depth to the income, or I'm sorry, not the income, but the depth to the, what was the Y? Yeah, stress level. So these are all still the same residuals, but at the same time, they are organized. So like maybe this point right here is moved all the way here because now we're talking about health. If the health level for that particular student was like a 4 versus, this dot was all the way here for the original residuals has completely shifted all the way to the left because this residual is like, you know, has a health level of 2 or something like that. So it's been shifted around. So what's the whole reason why I'm telling you this is that if they ever do this for you, you're no longer looking for the randomness in things. Rather, you're actually looking for pattern in this, and pattern is going to be great for this. Reason for that is you can actually now predict what's going to happen in terms of your residuals. Like, for example, as health increases, your residuals, it seems like it turns from positive to a negative. So as I expect the health to increase and further down the levels, what can I expect? It to be more negative down the road. I can clearly see that as a general trend in which what's happening. For graph 3, I mean, I can constantly just go like this and just kind of keep on increasing the income values. But what's going to happen is, I mean, I see the residuals being negative and positive and the negative and then positive once again. It's like random. I don't know what I can expect beyond this. It's very hard to extrapolate in something where I do not see any patterns for. So which variable, health or income? It's definitely health because there's a pattern in the residual plots here. This is not the same residual plot that we've been talking about from before, because remember, that's like this. Your y-axis only says just one straight up residual rather than the residuals like blah, 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 blah. So health is better because you can actually predict what's going on. If you look at the answer key, that's basically what it's saying. There's a strong association between health and the residuals. So again, you're actually like now trying to measure residuals to health and trying to look for patterns and things, trying to look for associations and things like that. Yeah, so that helps explain the variations, which helps you to predict what's going to happen in the future. So it helps explaining the variation. Okay. All right. So the last question was certainly confusing, but that's basically what it comes down to. So I think I'm going to stop the video and then move on to a different video for quiz 9. Yeah, that should be it for quiz 8. And thank you guys so much. See you in the next video.